Imagine this. You had 3 points on the surface of the Earth. Point 1, point 2, and point 3. Point 1 is on the equator of the Earth. Point 2 is slightly above the equator in the northern hemisphere, and point 3 is on the North Pole. Now, let's say the Earth traveled one full rotation, and so all the points came back to their original locations. Which point traveled the farthest? Well, point 1 was on the equator of the Earth and had to travel a much farther circle than points 2 and 3. Since they all took the same amount of time to complete one full rotation, that means point 1 was the fastest. So, we can say that things on the equator move the fastest, while things above the equator move slower, and things in the north or the south poles don't move at all. Now, let's say you kicked a ball straight from point 1 to point 2. If you look from space, the ball actually tends to curve left. The opposite is true if you kick the ball from point 2 to point 3. The ball actually curves right. Why does this happen? Well, the speed of the ground beneath you changes. If you're on the equator, since you move the fastest, you're going really fast. But if you're in the North Pole, you barely move at all. But if you kick the ball straight from point 2 to point 1, the ball won't change speed due to the law of inertia. So, since it's traveling slower than the equator, it'll shift to the left and fall behind. This opposite is true when it's going from point 2 to point 3. Since it's moving faster than the ground, it'll shift to the right and go ahead. This motion of things going right as they go to the poles or going left as they go to the equator is what the Coriolis Effect is, and it plays an important part in how things move in our world. It influences things from ocean currents to winds to even the direction of hurricanes. If you enjoyed this video, subscribe for more.